Good afternoon, class, or good morning, whenever you happen to be watching this video. So, for today's lecture, our goal is to cover chapter section 2.4. This is going to be mostly some business application. We've already talked about some of this stuff: cost, demand, revenue, profit, so on and so forth. We're not going to be taking those same vocabulary terms and going a step further in the business economics world and see how this stuff plays out in terms of calculus and derivatives. With that being said, it is a smaller section, so I'm aiming to try to make this video a little bit shorter today, since I know the last couple of videos I've posted have ran a little long. So we're going to try to make that better for you guys. So yeah, let's get started. So we are in, as I stated, chapter section 2.4. And just as before, we want to cover some vocabulary first. So the first thing I want to talk about is the word marginal. Marginal. Now, in business and economics, this refers to a rate of change. Rate of change. Now, what is a rate of change? A rate of change is a slope, or in other words, the derivative. So when you see things like marginal cost, in business, they'll use terms like marginal cost, marginal revenue, marginal profit, all just to mean the rate of change for cost. How is cost changing at a particular time? So marginal is the rate of change. This is literally what you might think it would be. It's just your cost function, and you take the derivative of it. So it's C prime of x. Same thing with marginal revenue. That's going to be R prime of x. And marginal profit. This is going to be P prime of x. So on and so forth. So nothing too scary there. This is just introducing what marginal is and how it relates to these business terms we've already discussed. So then I'd like to look at what is something called the average cost. Now, recall how in statistics, in order to take an average, we add up all our numbers together and then divide by the number of numbers we added together. Well, the same thing here. What is average cost? It is cost divided by your number of product. But in all of these business questions we've dealt with, what is the number of product? That is X. So for the sake of notation, we're going to use C with this bar over top of it to represent average cost. And this is going to equal the cost function divided by X. So no big deal, nothing too fancy just yet. But remember this formula, as we're going to end up using it later when we start having to calculate these things, so on and so forth. So let's keep going. Got a few more terms we want to cover. So our next guy is, we want to talk about consumption functions. Consumption functions. So what are consumption functions? Well, consumption functions estimate the, let me make sure I get this right. Yeah. estimate the country's, so this is on for a national level, it estimates the country's total annual consumption, hence the name consumption. It estimates the total country's annual consumption of consumer goods. So in other words, maybe you have an X number of some consumer good, and maybe you have some function that estimates how much of that good your country is going to consume during that year. Or in other words, this is very similar to a cost function because it's a number that's decreasing as a result of these goods. So think of this as kind of like cost, but it estimates something different. So the rate of change, and remember when you see rate of change, be thinking derivative. So the rate of change for such functions is called marginal propensity. So there's that marginal word again. Again, that's just referring to rate of change in business terms. To find the rate of change for a consumption function is the marginal propensity to consume. So it's an estimate for at what rate is the consumption going to change given they're currently consuming some X amount. And that can be useful for predictive models where you're trying to get a good guess at what a new consumption rate is going to be next year based on what it is this year, and so on and so forth, to consume. So there you have it, consumption functions. And then the last thing we want to talk about is, so this consumption function we can write as C of X. This is for the consumption function. But in relationship to the consumption, there's also something called, we're going to write as S of X. This is the savings function. So similar to the consumption function, a savings function is going to be referring to, again, the national level. What is the amount of a particular consumer product that's being saved each year? So maybe this is a product that's produced and then it's not eaten or it's not used, and so it's saved that year. So this includes any gains of a particular product and whatever amount of product is not used that year. So if at any given time we want to know how much product do we actually have left at a given year, so that's X, the number of product we have, the amount of product we have is equal to, at all times, the amount consumed plus the amount saved. This is the total amount of product in a given year. So this might be a little bit confusing. Why aren't we subtracting here? Well, that's because this X here, this isn't trying to estimate what's left over. This is trying to estimate what was the total amount of product that we had for a given year. Well, your total amount of product is however much you consumed plus what you had left over, which kind of makes sense. If you have a whole cake, you eat half of it and you save the other half. How much cake did you have in all? Well, you had a whole cake. You add both parts together. Same principle applies here. But what's interesting here is that based on this equation, if we take the first derivative, then, let's see, let me tilt this down a little bit. Then if we take our derivative here with respect to x, what's the derivative of x? Well, by product, or by the power rule, the 1 comes down, x decreases in power by 1, 1 minus 1 is 0, and so we have x to the 0 power, which is just 1. So 1 equals c prime of x plus s prime of x. So now we have this interesting relationship between the marginal compensity to consume and the marginal marginal propensity to save. Both of these derivatives, when added together, should equal 1 based on this equation. So go ahead and star that. You want to make sure you remember these equations. We're going to need them later for some example problems we're going to work through. All right, so there we have our vocabulary for section 2.4. We're now ready to take a look at some examples. So let's go ahead and do that. Switch gears here. All right. All right. So for our first example here, we're going to take a look at a word problem. And again, just as before, for the sake of, hold on, sorry, I'm trying to get this straight. Okay. For the sake of simplicity and time, I'm not going to write out the entire word problems here, but I'm just going to read it out to you, and these are the exact kind of word problems you guys are going to encounter when you work through these kind of questions. So here we go. So we have here, and we're going to switch to black. Suppose that a manufacturer has determined that the price of producing X units, so again, X is the number of units that we have. The price of producing X units of a commodity is given by P is equal to D of X, which equals 117 minus 0.25x. And the total cost is given by C of X. So in the case of this word problem, they spell it out for you. This is great and this is nice for getting used to these questions, but not all these word problems are going to spell it out so nicely. They might just tell you about what these things are doing, and then you have to put it together for yourself. But we'll see some examples of that and talk through it. So they give us here that C of X is equal to 225 minus 225 is right. The cost is 225 plus 2x squared. Determine the marginal profit for selling 16 units. So again, what is marginal profit? Well, that is going to be P prime of X. And this is a capital P, not a little p like up here. This is P for profit. So it's the marginal profit for selling 16 units. So we're looking for where X equals 16. Okay, well now we have all the parts written down and we're ready to work through this. So again, recall that in the word problem, it was calling this function here the price. Anytime you see price, think demand function. This is the price you can sell your product at based on how many X units you produce. So price and demand, one and the same. But in order to get to a profit function, what do we need? Well, recall that profit is equal to revenue minus cost. All right, well, they give us the cost function, so we're already halfway there. Now we just need to find our revenue function. What is revenue? Well, again, recall that revenue is equal to X times demand. Why? Well, demand is the price that you're selling your product at. But if you know what your price is, then price times the number of units you sell is the amount of money you bring in. What you're selling it at times the number you're selling, that gives you your revenue. So we can go ahead and calculate that. So revenue is equal to X times dx. So I'm going to go ahead and distribute an X in there. So we've got 117x minus 0.25x squared. Okay, good so far. So here's our r of x. And we can plug it in for profit. So profit is equal to 117x minus 0.25x squared minus cost. So distribute that negative here. Minus 225 minus 2x squared. So we can go ahead and combine like terms. We've got two squareds here. So negative 0.25 minus 2 is going to give us negative 2.25x squared plus 117x minus 225. All right, so there's our profit function. But remember that our question is asking for the marginal profit, or in other words, the first derivative of profit. So we'll go ahead and do that. So P prime of x is equal to, and again, all this is just using the power rule and the sum and difference rule that we learned in the last lecture. Because there's these plus and minuses, I can distribute my derivative and just do one piece at a time, and just remember to pull the plus and minus down. So we have this first one, we're taking our power rule. So the 2 comes down and we multiply. So 2 times negative 2.25 is going to give us a negative 4.5. X raised to the power decreases by 1, so 2 minus 1 is 1. Plus derivative of 117x, again we use power rule, the 1 comes down, so we've got 117 times 1. X, it becomes power 0. X to the 0 is just 1, so we're left with 117. And then lastly, for the derivative of constant, recall that we have from before this derivative of constant is just 0. There's no slope there. So minus 0. Now, we're ready to do our last step and plug in x equals 16 to find out what is the marginal profit when we sell 16 units. So, we're going to have here P prime of 16 is equal to negative 4.5 times 16 plus 117. And when we do that, well, I'll just go ahead and write it down. We get an answer of 45. And there you have it. That would be the answer to this question. Now, in terms of interpretation, what does this actually mean in business terms? Well, let's think about it. Remember, marginal profit is a rate of change. So what are we saying? We're saying that when x equals 16, so if we sell 16 units, then we expect the profits, because remember we're talking about marginal profit here, we expect the profits to do what? Well, we know that the rate of change for profits is 45. This is a positive number, so we expect profits to increase. Increase by how much? Well, increase by a rate of $45 per unit. So this is good. This is saying that if we only sell 16 units, then we expect over time after this point, we expect profits to increase. Well, that's great. So for this predictive model, we have that when we sell 16, we expect profits to go up over time. Okay. So then why do we really care about this? Really, we care about this because when you have these equations that model what your profit is, if we're trying to maximize that profit, then we care about what is the marginal profit depending on how many we sell. This becomes important for business planning, business modeling, when you're trying to decide how much you actually want to sell your units. How many of them do you want to sell? Because the more you sell, then there's more of them on the market, less demand, price goes down. And so this becomes very important if you're trying to maximize the profit for your company or whatever business model it is you're dealing with. So, good stuff. Let's look at another example though. So let's look at some other examples. Okay. So for this next one, it's a similar kind of question. And we're saying, make sure I'm looking at the right one. Yeah, here we go. Yeah, okay. So what we got here is we're told the total cost, so be thinking C of X, of producing X clock radios. So here we're told we're selling clock radios. Producing X clock radios is given by the function C of X. So again, here the cost is given, but that's not always going to be the case, and we've got some other examples we'll look at for that. So the cost is given as 300 plus 24x minus 0.4 x squared plus 0.1 x cubed. Okay, and we're told find the marginal, so again be thinking about derivatives, marginal average cost if x equals 4. So that's if we only sell 4 clock radios. So marginal average cost. Based on marginal, we already know we're looking for a derivative. So we move on to the next keyword, average cost. Well, what is average cost? Recall that average cost we write as this C bar with the bar on top. C bar of x is equal to our total cost divided by x, the total number of units we're trying to sell. So this is what we need to do in order to find our average cost function. So let's go ahead and do that. So C bar of x is equal to, and I'm just going to divide x into each of these terms, one at a time, in the cost function. So with the first guy, I'm going to have 300 divided by x plus 24, the x's cancel there, minus 0.4x. We have an x squared, so when I divide by x, I have 1 left over. And then plus 0.1x squared. So there's our cost function. Now for the sake of ease, when we try to take the derivative of this to find the marginal average cost, I'm going to go ahead and move this x up to the numerator, but change it to a -1. And the reason I do that is just so that now I don't have any fractions, and when I apply the power rule, when I take my derivative, I can just bring the -1 down and keep chugging along. So that's what we're going to do here. So when we take the derivative, so that's c bar prime of x, the -1 comes down. We have -300. X raised to the power decreases by 1, so -1 minus 1, this is -2 now, plus the derivative of 24, that's a constant, so it's 0, minus 0.4 plus 2 times 0.1, that's going to give us 0.2x. Now we have our derivative. And so that all that's left is that we want to find the marginal average cost when x equals 4. So we're just going to plug in 4 to get our final answer. So c bar prime of 4 is equal to -300 divided by, because I have this negative power, I'm just going to go ahead and move it back down to the denominator. So I'm going to have 4 squared minus 0.4 plus 0.2 times 4. And when we do that, and you can type that in your calculator, we're going to get an answer of -18.35. And there we have it. That's our final answer for this question. So there you go. This is how you would solve for marginal average cost given a cost function. But what does this actually mean? And let's look back at what this means in terms of business. Well, what we're saying is the average cost, since that's what we're talking about, so the average cost will do what? Well, marginal refers to a rate of change. It is how we expect the average cost to change when x is 4. Okay, so this is a predictive model for how we expect things to change given x equals 4. So we expect the average cost will change by how much? Well, we have a negative sign, so what do we expect the cost to do? We expect the cost to decrease. So the average cost will decrease by a rate of how much? $18.35 per unit if we sell 4 units. Or in this case, I think the problem said it was clock radios. So 4 clock radios. So what does this actually mean in more plain English? We expect our average cost to go down, which is good. If cost goes down, then we're losing less money to cost, and so our overall profit goes up. That's a plus. We like that. But what else does that tell us? Well, this is what's going to happen on average. So this is merely an estimate for what we think is going to happen to our cost function. So why do we do this? Why do we care about the average cost? Why didn't we just find the marginal cost instead of the marginal average cost? Well, we do this because when you're dealing with any of these functions, your cost function, your revenue function, what have you, all of these functions are estimates. They're not really dead on exactly accurate for what's going to happen. Now, sometimes there are some equations that are more accurate than others. It all just depends on the business models that the company makes and designs. But the whole point here is that because the cost function from the beginning was already an estimate, then in order to get a better ballpark idea of what's going to happen, we take the average of it. That's more of it's a better estimate for what we expect to happen, rather than if we just took the marginal cost. So that's why we care about average cost, and that's how you would do it. Same thing for if something asks for average revenue, average profit, what have you. You're going to use the exact same formula. You just take your revenue, profit, whatever it is, divide it by x to find the average that thing. And then the marginal is always going to be the derivative of that thing. So there you have it, and that's why we care about doing this kind of math here in terms of business. So we've done an example with marginal average cost. We've talked about marginal profit. Let's see, we haven't done anything with consumption functions yet. So let's take a look at those next, because those can be a little confusing for students sometimes. All right. So for this next example, we're looking at, so again, we're looking at a word problem here. And we're going to say, suppose that total national consumption, whenever you see this in a word problem, automatically start thinking about consumption functions. Suppose the total national consumption is given by a function c of x is equal to 200 minus 0.6 x minus 0.05 x to the 0.6 power. So there's our cost function, where x is the total national income. So x is total national income. Now the question asks for, determine the marginal propensity to save. Okay, so let's step backwards. What's marginal propensity? Well, that's a derivative. What's save? Well, that's our savings function. So what are we looking for? We're trying to find s prime of x. Now that's the thing with a lot of these questions. Oftentimes they'll just ask you, in this case, what is the marginal propensity to save? They don't tell you what is s prime of x. They won't ask it like that. You've got to know the vocabulary terms so that you can look for the correct equation. So here we go. We're looking for s prime of x. So how do we find it? Well, we already know from before that c of x plus s of x is equal to x. But if we take the derivative, which tells us about marginal propensity, then we have that c prime of x plus s prime of x is equal to 1. So here's the magic guy we're looking for. We know c of x. We don't know c prime though. But that's not a big deal. We can find c prime by taking our derivative. So that's what we're going to do. We're going to say c prime of x is equal to, the derivative of a constant is 0. The derivative of negative 0.6x, that's going to leave us with negative 0.6. And then here we use power rule. 0.6 times 0.05, that's going to be negative 0.03. x raised to the power decreases by 1. So 0.6 minus 1, that's going to give us negative 0.4. So there's our marginal propensity for consumption. So we're halfway there now. All we have to do is plug this equation in and then solve for s prime. So what do we have? We have negative 0.6 minus 0.03 x raised to the negative 0.4 power plus s prime of x is equal to 1. And now all we have to do is shift this over to the other side, and we're going to have s prime of x is equal to 1 plus 0.6 plus 0.03 x raised to the negative 0.4 power. Well, we can combine some like terms, and we're going to be left with 1.6 plus 0.03 x raised to the negative 0.4 power. And let me just double check. 1.6. Yep, and there we have it. That is our final answer, and that's a perfectly valid answer. Even though we have this negative power over here, don't worry about that. That's perfectly okay. That's a valid answer. It's a perfectly fine way to write your answer. And so there we go. We have found our marginal propensity to save. So there we have it. There's an example using consumption functions. Let's see. Yeah, we'll go ahead and do like maybe 1 or 2 more examples. I think you guys have got it at this point though. So next, we'd like to look at a word problem where they don't give it to us, where they don't tell us what the functions are, and then we have to kind of put it together based on the words. So here we go. So let's see. Let's look at this example. So, all right, we're looking for, this is a business that makes t-shirts. So, a supplier of t-shirts charges vendors, so charge, I see. So I'll read through it first and then we'll talk about it. So charges vendors for each order based on a setup fee of $50 and an item charge of $1.15 per t-shirt. What is the cost function, so that's what we're looking for the vendor? So this isn't from the perspective of the manufacturer who makes the t-shirts. Instead, we're trying to calculate the cost for the vendor who buys these shirts, and then this vendor is trying to resell them. So how do we do this? Well, we see what is being charged to the vendors to get these shirts. That is what is being cost for the vendor in order to do business. So this charge is the cost for the business, for the vendor. So what do we have here? Well, we're told for each order there is a setup fee of $50. So regardless, so we're looking for C of X. So regardless of how many items you purchase from the manufacturer, how many t-shirts you buy, it's always going to cost you at least $50. That's a flat fee. And an item charge, so and we've got a plus sign here, and an item charge of $1.15 per t-shirt. So for every t-shirt you buy after that, it's going to cost you $1.15 each. That's $1.15 times X. So there's our cost. So we found our cost function. The rest of the equation, or not equation, the rest of the word problem now says find the marginal average cost, like that other problem we worked through. So we already have our cost function. Now we need to find our average cost before we can find the marginal of it. So what is the average cost? Well, C bar is equal to C of x divided by x. So that's going to be 50 divided by x, but I'm going to go ahead and write that as 50x to the negative first, plus $1.15. So there's our C bar. Now we're trying to find the marginal average cost. So we just take the derivative of it. So C bar prime of x is going to equal, negative 1 comes down, we have negative 50, x raised to the power decreases by 1, negative 1 minus 1 is negative 2, derivative of a constant is 0, and so for our final answer, the marginal average cost is negative 50 divided by x squared. And there you have it. That's a final answer. It doesn't ask us for what the marginal average cost is for a particular x, so this is as far as we can take it. This is our final answer for this question. So there you go. We've covered some basic business terms and how they relate with derivatives. As we continue in this course, we are going to keep returning to these business examples and talk about revenue, cost, profit in these different senses. So it's going to be a recurring theme, and make sure that as we learn these new terms that you just save them away somewhere, because we're going to need them later in the course. So that's all I have for today, so I'm going to go ahead and end it a few minutes early. And of course, let me know if you have any questions, concerns, email me. We can talk about it during the Q&A today. And otherwise, that's all I have for you. So I wish you all the best of luck.